Well, welcome. In this video, we're going to be looking at how you can be able to find inverses of relations. Now, just remember that a relation is kind of a general term to represent any set of coordinates. Now, we can represent relations as tables, as graphs, or as equations. Well, in this video, we're going to be looking at how to find the inverse of a relation when it's set up both as a table, like what we have over here, and as an equation. So let's look at this first example. This first example is looking at Sally, who's babysitting some kids. And in that first table, on the far left there, we see that that information is given to us based on the number of hours that she works. So if she works 2 hours, for example, she's going to get paid $30. If she works 8 hours, she's going to be paid $120. So we would say that table is giving us the pay based on the number of hours she works. Now we could also flip that around, and we could have a situation where we look at how much she made and use that to figure out how many hours she worked. So if she made a total of $60, we could determine that she worked for 4 hours. She babysat for 4 hours that day. Or if she came home with $150, we could determine that she worked for or babysat for 10 hours that day. And that second table represents the inverse of that first table, which brings us to our first point here about relations, which would be that the inverse of a relation, when we're dealing with a set of points, is going to be found by switching the x and y for each part for each ordered pair in our relation. So that's all you got to do. So when we look at that table on the left and the one on the right, all we're doing there, the inverse is going to be that information switched around, where we switch the x column with the y column. Now, if we're dealing with a relation that's set up as a function or as an equation, it's also really simple. It just requires a little bit more work. To find the inverse in these situations, you're simply going to switch the x and y in the equation, but then guess what? We have to solve for y. So that is how we solve when we work with a relation, how we'll be able to find the inverse of those situations. Now, some other things happen. Now, remember earlier in this year we talked about how to find the domain and range. Remember, the domain is the set of x's that are graphed, and the range is the set of y's that are going to be graphed. Well, when we find the inverse of a relation, since we're switching the x's and the y's around, well, guess what? That means between those two, between the original function or original relation, whatever our domain and range was there, since we switch the x's and the y's around, the domain and range switch when we work with the inverse. So in other words, what was our domain in our original function is now going to be the range for our inverse. And what was the range in our original function is now going to be the domain for our inverse. Let's look at some other examples so you can see how this is going to work. So now we're going to look more at a relation and finding its inverse, which again is pretty easy. And we're going to look at something that happens then with the graph when we look at an inverse and its original relation. So let's go ahead and look at this example, and then we'll look at some equations and finding the inverse of those equations. Okay, so here we have this function that gives us these ordered pairs, -3 and 2, -1, 4, 0, 3, 2, 8, 5, 7, and 7, 8. So to find the inverse, it's going to be very simple. The inverse of that function, we just switch the x and y's around. Now when you do that, you want to make sure that you keep the negative with the number. So for example, watch what happens with our answer here. So in that first coordinate, the original relation, the original coordinate was -3, 2. The inverse is 2, -3. So don't make the mistake of saying it's -2, +3. The -3, the negative stays with the 3. So when you switch those, it would be +2, -3 for the inverse, and 4, -1, and 3, 0, and 8, 2, and 7, 5, and 8, 7. So that would be the inverse of that original function. Now, if you look over on the right, they've graphed the points here with our original function and for the inverse. So for example, 2, -3 would be down here. Then we have 4, -1 would be right here. Then we have 3, 0, and so on. So these points here that are red represent the inverse and the blue represent our original function. So if you look at this dashed line that they put in here, this dashed line represents something significant. If you recall from what we've talked about earlier in this year, that line represents the line y equals x. So any graph and its inverse, any set of points, whether it's a graph or whether it's just a bunch of set of ordered pairs, its inverse is going to be reflected over that line. That's really important to remember. But for a set of points, that's all you have to do. We just switch the values for x and y around. Let's look at this next example. So this next example, they give us the function. We need to find the inverse, but this time the function is written, like I said, as a function. Now remember, when we're dealing with function notation, that f of x replaces y. So you can also look at this as y equals 2x plus 5. So to find the inverse in this situation, all we do is switch the x and the y around. So notice all I did here is instead of writing y, I have x equals, instead of 2 times x, I have 2 times y. Now technically this is the inverse, but we don't ever want to leave it like this. We always want to solve for y. So if I wanted to solve for y, if I want to get y by itself, I have to undo everything that's over here. So we're going to take this away piece by piece. So the first thing I see is that I have this 2y plus 5 is being divided by 4. So I want to get rid of that being divided, that section that's being divided by 4. So we do the opposite. We multiply both sides by 4. So doing so, we'll get rid of the fraction on the right. On the left, we'd have 4x. Now we have 4x equals 2y plus 5. Now it's going to be a lot simpler from here. I'm just going to subtract 5 from both sides. That gives me 4x minus 5 equals 2y. Then if I divide both sides by 2, I get my inverse of the original equation as 4x minus 5, that quantity divided by 2. Now the next one looks slightly different. We have another fraction here, so let's walk through this one together as well. So here we have g of x. Remember, we can name a function by any letter, so f, g, and h are usually the common letters that we use. So again, that replaces our y. So in essence, this is the same as y equals x divided by 3 minus 7. Don't forget that you're starting these problems by finding the inverse. We want to make sure that you remember that you're switching the x and y here. That is always your first step. So I'm going to write this as, instead of y equals, as x equals y divided by 3 minus 7. Now my goal is to get this y by itself. So what we want to do is we can add 7 to both sides, and when you do that, we get x plus 7 equals y divided by 3. And then finally, to get y by itself, and this is where you got to be careful, we are going to multiply both sides by 3. But when you multiply the left side by 3, please make sure that you multiply the entire quantity of x plus 7 times 3. Don't just multiply the x. Everything on the left gets multiplied by 3. So then that gives you an answer of 3x plus 21. Would be your inverse to the original function. Well, as far as our objective for this first lesson, that would be it. So remember, the objective for this lesson was that to make sure that you can find inverses of relations. So that is it for this one. So in the next video, we're going to be looking at the next objective. And the next objective would be that you'd be able to determine if an inverse is a function. So go ahead and make sure you watch that next video for this section.